Good afternoon. Welcome everybody to this last session of this first wonderful day of our Complexity Conference. The next speaker will be is Roland Fletcher. Roland Fletcher is professor of theoretical and world archaeology at the University of Sydney, where he worked since 1976, implementing a global, multiscalar, and interdisciplinary approach to archaeology that integrates research, teaching, and service to the community. The most amazing project that they have at Sydney University, according to me, is the Angor's research program, which is directed by Roland. It's a great international and interdisciplinary project, and I hope Roland will tell us something during his talk. No, not today. It was the talk that he gave us in January 2014, coming here for the Heritage and Complexity Science Conference, and we will see the follow-up today. His work systematically defines the relationship between complementary but different scales of interpretation and explanation, and specifies the fundamental role of non-correspondence between materiality and social life in understanding the outcome of change and the processes of cultural evolution. Roland's approach offers a new perspective on the materiality of human behavior across a wide spectrum ranging from the evolution of hominid behavior to industrialized warfare, and from the settlement patterns of hunter-gatherers to the limits of low-density urban growth in the agrarian and industrial world. Today, he will speak about the structure of emerging cultural patterns, 100,000 to the president. So please, Roland.
First of all, I'd like to give my thanks to Paralimis, to Dan, and to Steve for your encouragement and your goodwill. Thank you. It's a great pleasure to be here. It seems to me that today we have to bring together a very diverse range of intellectual fields and perspectives in order to deal with the situation which we are facing. I, as you would realize, am interested in very long-term patterns. I've been deeply impressed by watching the illustrations of short-term and medium-term patterns. Today, what I now want to do is to look at a very long pattern. I'm always deeply mindful that a teacher of mine in class on art history once said, 100 years is a very long time. 100 years is less than the standard deviation of most radiocarbon dates for archaeologists. I want to start with a very unusual device, which some of you may know about, called the Antikythera mechanism, which was found in 1900 by a diver in the Aegean. It's a complex piece of machinery, and it's essentially in the wrong place and the wrong time. We do know that the Greeks were making complex machines, but this is a really quite remarkable object. It's a multi-geared system, and it's a calculator predictor for looking at the structure of the solar system and time. This gives you some idea of its complexity and its precision. There's the original piece on the right and the restored piece on the left. And this gives you some idea of what at least part of the mechanism would have looked like. The point of me illustrating this machine is that this is a capacity that was possessed by classical Greece, but it's a capacity that was used to do nothing more than this. Yet it could have been used to do something like this. The Babbage engines were an effort to actually make complex calculating machines in the 19th century. The interesting absence, of course, is that, to the best of my knowledge, the classical Greeks did not have a zero. So the machine technology that they possessed and the accuracies and precisions they had, they couldn't implement. The point about this is to emphasize that if you look at the archaeological record, you don't actually see an even, steady progression of development through time. What you actually see is an extraordinary patchwork of aptitudes and technologies, underused, used for purposes other than we would use, and you see technologies and techniques coming into use for purposes other than the ones they will eventually serve. It's not a neat linear pattern. The significance of this is that something like the Antikythera mechanism is at odds with a very sophisticated convention which we have used to organize the information about the human past since the 19th century, derived really from the work of the great evolutionary philosopher Spencer. And this is the concept of stage theory, of successive stages of elaboration, each of those stages characterized in geological terms by a particular kind of type fossil, like steam engines for the industrial world, for example. Broadly, 3 progressive stages were recognized even in the 19th century. One of the reasons these 3 stages were recognized was, of course, that in the 19th century, Europeans were going through the third of those great transitions, broadly called the Industrial Revolution. It was clearly understood that there had been 3 great changes in the way human beings organized themselves since the end of the last glaciation. The development of sedentism, villages and agriculture, then the development of cities and literacy and the state, represented by cultural materials like writing, and then, of course, the great change that was occurring in the 19th century. The problem with this, of course, is progressive. It has a whole series of premises about superiority and inferiority built into it, and it is non-scaled. It is actually a value-based model rather than a scalar model. What's actually buried inside these 3 stages is something quite different. The phenomenon that's hidden inside them is 3 great transitions in settlement size. Very roughly, the first one, to what we call sedentary, agrarian, village-based communities, is an increase to settlements larger than about 1 hectare in extent. Similarly, with the first cities, this is a move to settlements larger than 100 hectares in extent. And the Industrial Revolution, the beginnings of the great expansion of places like London and Paris, is a move beyond the maximum 100 square K of the great compact capital cities of the pre-industrial world, like Chang'an in China and Edo in Japan. You notice that once you start looking at the past in these terms, you have a scalar relationship which you can begin to pursue. The point about the archaeological record is that in some ways it's extremely simple. One of the things we have done for many, many years is collect site sizes, how big archaeological sites are. And if you plot up this data at all sorts of different scales, you see patterns like this. There is a real phenomenon going on between 8,000 and about 6,000 years ago in Southwest Asia, tied up with what we call agriculture and sedentism, where there is this massive jump in the size that settlements can reach. You see exactly the same thing if you do the plotting of site sizes for what we think of as the early urban societies, and you see exactly the same as I'll show you in the industrializing transition in Europe. Overall, the pattern is extremely simple. Before one of these great takeoffs, you get this characteristic distribution. It's really obvious. There are lots of little sites, some medium sites, and very few. And almost no settlements get up to that limit size of either 1 hectare or 100 hectares or 100 square k. The majority of settlements are in the lower third of the size range, which is relevant for a point I want to make later on. The second point to note is that once one of these great transitions begins, the takeoff rate in the growth of the settlements, so that's the size of each settlement, is astronomical, proportionate to the previous period. And very roughly, and very interestingly, when you plot up these takeoff rates, you notice that the rate of increase for each of these three transitions goes up by a multiple of 1,000. So the boundary condition for size goes up by a multiple of 100, but the rate of growth, once a transition begins, goes up by a multiple of 1,000. That has some very serious implications for our future. What is interesting when you look at this record is that you can understand each of these transitions as a solution to a set of problems about interaction and communication in communities which are expanding in size and expanding their settlement area. The critical point about this is that the mechanisms for managing the three key things you have to manage, space, time, and sight and sound, are material. Writing, for example, is a method for managing communication, a material method for managing communication that you have to have as increasingly large numbers of people are trying to communicate with each other, and you are trying to manage increasingly large numbers of people. Instead of these characteristics like writing and sign systems being type fossils for the takeoff, what you actually find when you look at the archaeological record is that they are prerequisites for it. These characteristics, like great monuments, durable walling, multi-room space, have to predate the takeoff. They are the preconditions for the takeoff, not the signature of the takeoff. So, for instance, if you look at China in the period before the takeoff of its great initial urban settlements in the second millennium BC, what you find is that the characteristics which made those great cities possible all occur and have their ancestry in very small settlements, less than 30 hectares in extent, over the preceding 4,000 years or more. The prerequisites occur randomly. They can occur on their own. They can occur in various combinations. And they can occur with other cultural phenomena that they are never associated with in the future. This is a really random process. If you plot it up, for instance, for China, for the period from 7,000 BC down to the arrival of the great cities in here, what you find is that these various kinds of prerequisites are occurring all over China, and they're occurring with no particular pattern. Most distinctly, the Chinese script, instead of having one ancestry, has 6 or 7 ancestries. There are 6 or 7 different script systems in use in this period, but almost all of them vanish. So this is where the urban takeoff occurs here. This is the prerequisite antecedent period. If you plot this on a map, this is the location where the growth of settlements over 100 hectares in extent occurs, and this is the distribution of the prerequisites. There is simply no simple relationship between them at all. They are around in the landscape, and what is happening in the growth of the cities is that those characteristics, when they come together, allow these great takeoffs to occur. They don't determine that they will, they simply allow that they can. What you get out of that process in China is these enormous enclosures like Zhengzhou, these massive, massive earth banks around them, and the great palace complexes inside, and then, of course, the residential space, the ordinary residential space of tens of thousands of domestic inhabitants of these cities. When you go to Europe and the Industrial Revolution, you see the same pattern. The majority of settlements in Europe were less than 30 square k in extent immediately before the Industrial Revolution, and most were much smaller. In this period here, and going further back in time, you have the development of all that machinery and all those tools that allowed the great cities to expand. The steam engine, for instance, is not developed in London, where it's exploited. It's developed in small mining towns far up in the north to move coal, not to move human beings. Its original function was not as a person mover. One of the great features of the industrial world is, of course, the conversion of time to money. To convert time to money, you have to have clocks. You have to be using clocks highly systematically. But the ancestry of clocks is much older than the context in which it had that use in industrialization. They're used predominantly early on in ritual contexts, like churches. And then with the expansion of the clock industry in the very small towns of Switzerland, you get the creation of a prestige, elite clock production, where clocks are being used very strongly as part of the management of the social life of the elite. They're not being used predominantly to manage business, money, transactions, industry, and production. These are classic examples of prerequisites. What all these prerequisites do when they come together, brought together by enterprising people, is you get the takeoff of a place like London, which takes off at a rate of 5,000 square kilometres per century and requires these titanic supply systems to develop. This is the cattle market of London in the late 19th century. Just to realise this for you, it's much harder to do for the earlier settlements. This is what happens to the growth of London. The reason for the two pictures down below is I'm an Ealing boy. I grew up in Ealing, and I grew up not very far away from this shop down the corner. This is the main street, Northfields Avenue in 1903. That's the main street in 1906. This is the magnitude of the transformation that is occurring. I actually knew an old man in Ealing who had remembered the later stage of this process, who said, London came over the hill, which I have never forgotten as a description about urban expansion. I want you to remember this and this phenomenon of what the Industrial Revolution was like for the people who lived inside it, with the acceleration rate of growth going up by a multiple of 1,000. Bear that in mind when we get later on in this talk. Now, obviously, one of the questions that one needs to ask is, what is the timing of these transitions across 1 hectare in extent, across 100 hectares in extent, across 100 square K? And there's some interesting clues. Obviously, you can start measuring the transition times in the archaeological record, but it turns out that there may actually be an earlier one. As you notice, if you have transitions at 1 hectare, 100 hectares, and 100 square K, you should in principle have a smaller one at 0.001 of a hectare, and you should have another one at 10,000 square K. Notice that 10,000 square K. Two sets of processes are going on. One is that there is a trend in the development of compact settlements. And all this discussion about transitions in relation to these sizes is solely to do with compact settlements. And it's to do with the fact that compact settlements generate immense scales of stress in communication and interaction. And the prerequisites are resolving that stress. The other path you can go on, which is the other one that I've been working on, is a trajectory to very low densities. The interesting thing about low density trajectories from all the records we have is that these are terminal trajectories. You go down to low density, that's where you stay. And there is no future. When those low density systems drop out, they are replaced entirely elsewhere by quite different settlement patterns. And I'm not discussing at this point this trajectory, though please feel free to ask about it if you would like to. There is some indication that relates to the question that David was asking earlier about group size from the work of Robin Dunbar, that if you look at brain size in relation to group size, which is the work he's been doing, you see this interesting trend in brain size. And the really striking transformation, which Peter Hiscock, my colleague in Australia, and I are getting interested in, is this bit here, where ochre, the cultural material, the use of red ochre, begins to appear in sites. And it begins to appear at a point where there is a quite abrupt increase in site size and site visibility, and also in the brain sizes of human populations. There appears to be here a relationship between a cultural phenomenon which allows signalling in various forms and the size of groups. So there may just possibly be an earlier transition, an earlier jump in settlement size at that point. We don't know. We know what the material looks like. This is the ochre that is found in archaeological sites. This is some indication of the range of sites where it's found. This is a quite definite archaeological phenomenon. It gives us a small clue about the pattern of the transitions in site size. If there is a transition down here at 0.01, there's a zero missing there, this time between transitions is very slow. It's way over there somewhere. The second set of transitions from a 1 hectare transition through to a 100 hectare transition varies in different parts of the world from about 5,000 years to about 3,000 years. It's faster in the New World, curiously, than in the Old World, and occurs much later. So the angle of this line is an indication of the rapidity of the shift from one transition to the next. The next one is relatively straightforward. You either peg it at 5,000 from initial urban through to the industrial transition, or you peg it from some index of the beginning of settlements over 100 hectares within the European mainland, which would be somewhere around here, which gives you about 3,000 years. So the general indication is that this was very slow, and the transitions are either constant or slightly accelerating. The significance of this, however, is that if you have these transitions at 1 hectare, 100 hectares, 100 square K. You in principle have another one, which is ahead of us for compact cities. The key thing you need to know is that we have no cities in the world anywhere near 10,000 square K which are compact. Because a compact city that covered 10,000 square K would have a residential population of between 100 to 150 million human beings. We have big cities on this planet, but they're all sprawling, low density, spread out entities. They're not compact. Now there's some other slight clue that this process is accelerating, that the transition from where we are now to a 10,000 square K transition is speeding up. This is some data on energy consumption by human beings collected by Morris from Stanford, which suggests that when you get to the 100 square K transition, this is the Industrial Revolution here, we have a far more rapid, substantial expansion in our capacity to consume energy. The implication is that whatever is going on after the Industrial Revolution has accelerated more than the preceding periods. So what's the significance of all this? Continuing with this proposition about what is going on in our future, these are the acceleration rates for each of the preceding known transitions. If this increase continues, when a takeoff occurs beyond 10,000 square K, the rate of growth will be 5 million square kilometres per century. If you think that is absolutely improbable, go back to 1800 and envisage how in 1800 you would have thought about a 5,000 square kilometre rate of urban expansion, which was just about to land on you. If there is a future transition, it has some interesting implications. One, of course, is that we are in the lower third of the size range of that transition for most of our settlements. So in principle, in our settlements already, some of the prerequisites are coming into being, which will be of consequence for that transition. But they will be being used, and they will be in contexts that do not relate at all to their future use. Something that we're using to put coloration in chewing gum may be the basis for a future power source. I'm being facetious in that case. Let's have a look at the seriousness of what this takeoff would consist of, because it has some interesting implications for innovation and some interesting implications for what we think about technology. This, as you are all aware, is my country. This is Australia. That's where almost everybody lives in Australia, which is almost nowhere. That's just to give you some reasonable relative size. That's how big Australia actually is. There sort of ain't nothing between the East Coast and the West Coast. That's what 5,000 square kilometres of urban expansion would do in 1 century. What that means, if you think of that rate of expansion, is that New South Wales, which is where I live, and Victoria, this area would be completely urbanised in 20 years. Just hold that in your head. If you say, no, not possible, can't be, join the club. Join all the great analysts, economic interpreters, highly intelligent people who judged the limits of the size of London in the 17th and the 18th century. They were very good analysts. They were also wrong. They were wrong because what they hadn't envisaged was that what was going to arrive between the 16th and the 19th century was a set of prerequisites of which they had no conception and which would have consequences they could not imagine. The construction technologies required to make London expand at 5,000 square kilometres per century and to be managed simply were outside their imagination. Let's have a crude look at what might be going on. Very roughly, if you look at each of those transitions, they have a fairly obvious development, a prerequisite that goes with them, which assists the delivery of information. It's fairly obvious that writing would do that for the early urban transition, and it's pretty obvious that mechanized printing would do that for the Industrial Revolution. We now have digital systems developing. So let's have a look at the status of those digital systems. Mechanized printing has its ancestry officially. Curious what the real history would be in objects like the Gutenberg press, produced in the 15th century, in what I must emphasize were extremely small towns. This is not a technology that is being invented to run industrial cities. It's being invented to produce Bibles and broadsheets. Man who needs to be greatly respected. By the time you get to the Industrial Revolution and the beginnings of the expansion of cities, you have to have the Victorian printing press. And before the turn of the century, a mechanized printing press was the height of a 3-story building, and the people who ran it worked inside it, not outside it. These were huge pieces of machinery. So what you're looking at in the Gutenberg press is an ancestral prerequisite developing in a relatively small settlement in the lower third of the size range. On the right, you have the new supercomputer of the University of Technology. It is developing in the lower third of the size range. The implication is that it is somewhere on the proportionate scale of the Gutenberg press. The technical innovations that will be required for the development of settlements beyond 10,000 square K in a compact form are not even in our imaginations. This is an exceptionally primitive object. Exceptionally primitive. So is the smartphone. The smartphone is probably about at the same status of the early tokens in Mesopotamia, which are the 4,000-year predecessors to writing. That's serious stuff down the bottom. That's real high-grade technology. The recent article in The Economist about the smartphone is making clear the phenomenal impact of this device on the right-hand side. I find this quite insightful because it's helping me to begin to understand what the impact of that was in Mesopotamia between 7,000 and 4,000 years ago. That's a little introduction to the question of how do you expand a settlement at 5 million square kilometres per annum. My guess, I'm quite happy to be corrected, but my guess is you are not going to do that with mechanical technology. What you have to start considering when you look at these transitions is get out of that stage model. technology, mechanical technology, is not the pattern of the long future. Technology, mechanical technology, is the pattern of our bit of time. It's not the long future. There is no future of great spaceships like Star Wars. That's just us extrapolating our pathetic little present into the future. The implication of this is very straightforward. What we're actually seeing is that if such a transition, a 10,000 square K transition occurs, it will be occurring with innovations staggeringly beyond anything that we're looking at the moment. But the prerequisites, some of them, may actually be hanging around in our cultural world. If you want to envisage just how serious such a cultural transition will be, you're used, I'm sure, most of you, to the notion that you can be 15 minutes late for a meeting, even with your Vice-Chancellor, provided you phone in and say, sorry, 25 minutes, half an hour, you reschedule. Well, I worked for several years in West Africa with farmers, and what you said to them was, I'll see you next week, or I'll see you sometime tomorrow night. And if you asked them when the bus was going, they smiled quietly and said, oh, sometime today, maybe. That's social time. One of the things that's happened in our transition is that social time has accelerated enormously. If there's another transition, social time will accelerate again. Try and imagine what such a social world is going to be like. You can then try and understand how somebody in the early 19th century would understand our world with iPhones. How incomprehensible and bizarre our behaviour actually is. So we're having to think now of the possibility of scales and forms of innovation of a kind we have never imagined. The significance of this is that we can envisage the classes of material prerequisite we require. They've got to manage space, time, sight and sound. We have some idea of the magnitude of the innovation that's involved. We're not stupid. We should be able to begin envisaging what the innovations would be. You just have to worry about one thing. If we now know that there is going to be a next transition, we have just accelerated it happening. If you're on the ball and you've got the innovations that will drive that, you are going to make a lot of money. But bear in mind that you will be making a world as unstable as the one we created through the Industrial Revolution, with dire consequences for enormous numbers of human beings on this planet. Thank you.
Thank you. Does it work? Thank you, Roland, for this very inspiring talk. I think we started the day with one topic, we are ending the day with another topic, and I would like to open the floor for questions because deeply connected. I don't know which of who. I will start with Sander there.
Is this on? Yeah. Roland, first of all, I love it when archaeologists really think about the future, and I think that doesn't happen very often, and we need to have more of it, okay? And I'll try and contribute my little bit tomorrow, which in some ways goes similar. But I have one real issue with the way you see this as sort of an expansion of dense urban cities. My sense of it is that basically in order to sort of understand the size scaling of the cities, you need to look both at the information and at the energy aspect. And that from the energy aspect, energy has been basically a constraint all along. Information is what has been driving the size of the city. Now, for a very long time, the density of the cities was determined by the fact that although you had written communication, a lot of it was oral, and therefore search times had to be reduced. And the reason for a lot of the density of the cities is actually that reduction of search time. So the question that one then poses is, okay, with the current information revolution, where search time is no longer expressed in physical time, do you actually move towards these kinds of huge agglomerations? Because the other thing that I think is important in the way you present the argument is that cities are basically nodes in a network. And you have not really talked about that aspect, which I'd like you to talk about now a little bit to understand this dynamic a little bit better.
Sure. Thank you very much, Sander. There are several things to do. Am I still transmitting? With the economic issue, I've deliberately, you noticed, left that out of this discussion and only talked about the material prerequisites that would manage interaction and communication. And there's a very particular reason for that, is that in the transition which we know best, which is the initial urban transition, there isn't a correlation between the prerequisites being present and an economic energy transition. Very interestingly, two of the initial cases, Old Kingdom Egypt and the Indus Valley, do not appear to have had an economic change. They're doing all sorts of economic things, but there is no basic transformation to their resource supply system. Karl Butzer made this point for Old Kingdom Egypt a long time ago. Irrigation, for instance, in the systematic sense of enhancing yield, only comes in the Middle Kingdom in Egypt. The result is that the early settlements are all relatively small, and in the Indus system, the system actually falls over. So one of the really important things to notice about this argument is that this is not a deterministic argument at all. You can have the prerequisites that manage interaction and communication, and they can start the growth of the settlements. But if there isn't an economic transformation as well, that takeoff can't be sustained. We've been deceived by the Industrial Revolution because we got the two as a package, and we thought that that was an inevitable law. But the archaeological record says it's not. So that's the first one. The reason for my not doing this is that I think the whole field of economic analysis in the archaeological record really needs to be reappraised. And we're hearing about an astonishing range of ways of thinking about dealing with this problem, which I hope we will be able to use, and that you've been one of the initiators. Now, the second one was about density.
Density and network.
Okay. The network one I'll deal with briefly because I have concluded that it's outside my competence. What I've done is I've started with what I can do, which is to play with places, I can see London. Obviously, the next step in redefining the model that I've been describing, which is very rudimentary, I must emphasize, is that you would have to move into a network concept. How does the main node expand and how do the other nodes expand relative to it? That'll be a fabulous piece of research. And the Industrial Revolution would be the target. It'd be very difficult to do with the earlier transitions. But the Industrial Revolution is just magic. We've got the data. Now, the density one is really interesting. In the main, people live in relatively small settlements, and they tend to stay relatively close together. But in the main, most settlements do not move up into the high density, large size band. In the pre-industrial world, for instance, there were somewhere between 30 and 40 cities in the whole world that got into that zone. Interestingly, when you look at the pattern of settlement expansion, one of the things we now know for the pre-industrial world is that there is a significant trend to drop to lower density, and in rarer cases, to move to very large size. 200 square K in maximum in the case of the Maya, 1,000 square K in the case of Angkor, the place I work on. But the critical point in relation to the point you've made is that these are multi-centric. They do have a core, but the way they function is to open out, like our cities do, with multiple nodes. And that's the way those low-density systems work. The point I want to make, just using this diagram, is that what is happening on the planet at the moment is that we are moving in aggregate to urban low density. We have 50% of the human population progressively moving towards living in this pattern. The thing I'm concerned about is that what the archaeological record of Angkor, the Sri Lankan cities and the Maya cities indicates, which we're going to publish shortly in Antiquity, is that this is a terminal process. There is no way out of this. Just think in terms of trying to organize a policy that reduces the aerial extent of a city. Work out what you would do to real estate value if you tried to do that. That's a very serious problem. So there is a critical series of issues here about density, compactness, and long-term operation. That really is the great issue to pursue. So thank you.
Please, is Carlos now?
Well, thank you for a very stimulating talk. I was wondering that perhaps some of our digital technologies are actually redefining what we understand as a city, because many of the telecommunication technologies are actually bringing the benefits that people have by living together beyond physical location. So if we redefine what our concept of a city, then the transition you speak about is not so provocative if we understand that people, let's say agglomerations of 100, 150 million people would be distributed in several cities which exist already, because given the tendencies of the reduction of the increase of population on the planet, it would be difficult to reconcile city growth, as you mentioned, if it's in the same physical location. So perhaps your predictions would be non-problematic if we consider actual cities merging through digital technology and having the benefits of urban area distributed across large areas, and that could also explain the huge increase in urban area size, because it would be basically aggregation of current cities.
It's an area density issue. First of all, notice that this phenomenon has occurred probably 3 times in the Industrial Revolution, is that each time we innovate things which are only available to core urban populations, after a while you find that people in Scotland have got them. It's a bit annoying, but they do get them. Exactly the same is going on at the moment with digital communication. Now, you do make the very sound point, and Simon made it as well, that with the modes of information shifting that we now possess, you don't have to be co-located. You can spread out enormously, and you can get stuff sent to you. That's another possibility. The thing to bear in mind is that the multiple city model which you described is simply the low density model. Most of these are conurbations, as London is. Yep. Ealing was a little village where I grew up originally. It wasn't a village when I grew up there, but it had been. The key thing that happens, however, is that we're dropping to very low densities. And disturbingly, you might not like to hear this, we have an awful lot of space on this planet to spread low-density cities over. An awful lot of space. One of the embarrassments of looking at Google Earth is to see how little of the planet we actually cover with cities. So we can go on this spread-out model for a very long time. Places like the East Coast megalopolis are, what, 440,000 square kilometers or more. They're way, way larger than 10,000 square K, but they're not high density. If you drive through the East Coast megalopolis from south to north, you see buildings all the time, and you see open land all the time, and every so often you're in one of these dense cores in the middle of a place like New York. But it's a huge, sprawling, low-density structure, and its average density is less than 10 persons per hectare. What we're talking about with a compact settlement with 10,000 people in it, of 10,000 square K, is densities of 300 to 400 persons per hectare or higher. So this is really serious packing. We have nowhere on Earth that is doing that. Nowhere on Earth at all. So the interesting issue is which of these urban models will we go on? It's a very serious problem.
Maybe in Dharavi?
Hmm?
Maybe in Dharavi, the slum in India?
Well, one of the disturbing comments that's been made both by Kilcullen and by a guy who wrote City of Slums is that the urban warfare we're seeing at the moment is the preamble for the future. It's the technology for managing future cities. That's a pretty ugly model, but it's not an unsound one. That would be worth worrying about.
Thank you for the very interesting talk. When I was listening to your talk, I couldn't help wondering what would happen to Singapore. When we're talking about 10,000 square kilometer city in the future, we know that Singapore has only 600 square kilometers. So does that mean that 94% of this future city will be outside this country? And then if that turns out to be our future, how could this country or how should this country interpret this prediction? And is there any way that this country should, still expect that it can keep to be, how to say, developed, prevail, and so on, when it's account for only 6% of a big city?
Well, there's a very interesting set of issues. I was stirred to actually look at Google Earth on the plane because I'd been asked if I would speak to your colleagues in Singapore on this issue. The example would be to look at Hong Kong. This is not meant to make you happy, I'm afraid. Hong Kong we think of as a place. Hong Kong is a tiny outer suburb of the Pearl River Delta complex, which has somewhere between 50 and 80 million people in it. It's just a little tiny point in relation to that huge area. What struck me, and I have to say I was geographically ignorant about this, and I don't know why, is that not far up the road you have Kuala Lumpur. Kuala Lumpur is going to connect up with all the towns to the south down to Johor. Singapore is going to become part of a Singapore, Johor, Greater KL urban complex. What that does for the political management of Singapore, I truly don't know. I have a feeling that you guys are savvy enough to win that one. The critical thing to bear in mind about this is that if we're going to have cities of 10,000 square K, which are compact, developing in the world, they're not going to develop in China, because the giants, Shanghai and Guangzhou, have already gone to low density and they can't come back. Mumbai in India is small enough to make a compact transition. So would this area here. And if you had a transition to a nearly 10,000 square K compact city between here and KL, you would have that population being carried by nearly 1 billion human beings in the greater Southeast Asia area. You'd have to have about 1 billion people to prop up 100 million people in a city. So the implications for looking at the longer term and deciding what Singapore is going to do about urban planning in Malaysia becomes a really interesting question.
Thank you.
Yeah, I just wanted to look backwards, and in particular at the issue of prerequisites for transitions and the prerequisite for the earlier transition before the Industrial Revolution. And in particular, look at the New World. And you gave some data, and you mentioned the New World was slower and later.
Yeah.
And I'm wondering whether one reason for the lateness there was the fact that in some places there were settlements, there were empires which didn't have writing. They might have had some means of communication at a distance, but I'm thinking in particular, I think of the Incas. Correct me if I'm wrong, but I don't think they had writing. They found it very strange that the Spaniards were able to communicate at a distance. And I'm wondering if that meant that's one reason why there was this delay in the New World. I know other parts of the New World did have writing, but not that part.
There are two answers. One is that I would suspect that much of the delay in the New World is that they don't have major draft animals, except for humans. The ones that you have in South America, you can't harness. You can herd them, but you can't harness them. So I think there's a significant factor there. To go back on the issue of information systems, in fact, all of the New World societies had very substantial material communication systems. The Spanish, for instance, remark upon the power of the quipu, the knotted string system of the Inca, as a method of recording information. The Inca, you also have to bear in mind, are 1,000 years down the line from the beginnings of urbanism in Peru. And in the Moche culture, there are actually signs marked on the bricks of the pyramids, which look like a sign system assemblage. And Larco Hoyle, who I think is a remarkable Peruvian researcher, argued years ago that the decorated beams that are illustrated in the Moche system being carried in bags are actually an information system. So my view would be that all of the early urban systems had information management systems of some sort. The interesting thing about the quipu, of course, is that all it is the llama herder's piece of string for keeping track of his animals, which he either knotted around an animal's neck or around his wrist. And it has been inflated into an imperial management tool. And it's worth noting that the Spanish took the quipu so seriously that when they got hold of them, they burned them. And if they got hold of a quipu reader, they killed them. And they killed them to destroy the information system of the Inca Empire. So that was a pretty formidable information system. Not writing. I use writing as a convention, but really it's a material information management system that all these places have. But the late development in the New World is another really interesting problem to pursue, because there's a very substantial agricultural base in the New World. It's just this strange issue about the type of transportation system you're using. Could you indulge me for one moment? This is one of my favorite pictures. These are wheeled toys from the formative period in Mexico. The Mesoamericans knew about rotary motion. They used it either to make ritual objects or for kids to have something to pull along the street. That's an example of a prerequisite you might stare at and miss. And it has an interesting characteristic. In China, the Chinese put sails on wheelbarrows. Can you imagine what the Aztecs would have done to the Spaniards if they'd had that transportation technology? Oh man, Cortes would not have got very far. But they didn't. They never used it. It was in front of their eyes. They knew how to do it. They knew what it was. And they never took it up their technology scale. Thank you for the opening. Much appreciated.
Just a question on, to build on some of the other questions. Just to build on some of the other questions, which was talking about network, and then we seem to be getting into the possibility of a Singaporean invasion of Australia to solve its problems.
Well, we could use some man.
Absolutely. There's nothing else there. And
That's true, if you look around.
the population densities and growth of urbanization seem to me to have been based on economic, let's say, needs and sudden expansion rather than population needs. And indeed, I think you said that the two of the examples that didn't have that economic was unsustainable.
Yeah.
So I just want to check my understanding on that, because when you look at the sort of population densities you're talking about, and 300 people per hectare, etc.,
Yeah.
I'm just wondering if we've actually already done that with Facebook.
In terms, well, this is where the interesting question will arise in terms of several of the comments that are made. What we're doing is we're transforming the density of the engagement space. And we have never done that before. Humans have never done that, and we now have 50% of humankind who can get into doing it. I vividly remember, 10 years ago, being in a small village in Thailand, and there was a young girl standing by the street, actually astride the storm drain, talking on a mobile phone. The implications for what will happen, just a recent article on smartphones is about precisely that issue, is we're moving into another agenda of a communication space, information space. What I don't think that will alter in the end is the implications of bodies on the ground in unit space. And the key thing is that nowhere in the world are we anywhere near the big spaces with big populations in them. We have big populations who are really spread out, but we don't have any who are really packed together. And we have no notion of how we would manage those.
Would we need to, if it's about space, time, sight and sound,
That's right.
would we need to address that issue using a building concept with grounds? And I know the archaeologists might be, in a couple of thousand years out of a job here, but would we need to address that issue using the old thinking that we need to build stuff to be?
Well, my worry is that if you envisage that 5 million square kilometres per century, it's very hard to envisage that it's going to look like the kind of stuff that we live in. And yet all this model of mine is predicated on having physical barriers to interaction. You know, that invaluable device of the teenager's bedroom that they can go into and shut the door. Now, are we going to be in a situation in the future where we have a city the size of 2/3 of Australia and teenagers are not going to want to go into their bedroom? I doubt it. But I can't envisage how you could possibly create such a space. I just cannot see how you could do it. What are we going to do? Breed cities or something? You know, what are we going to do with this stuff? We literally can't. We literally, I think, can't envisage the technologies that would do the job. Just as if you asked somebody in 18th century London how you would build underground stations, or you asked an Eskimo about a smartphone. The problem is, the second you show an Eskimo how a smartphone works, you've got somebody on a smartphone. You know, we're pretty clear. So there's a huge disjunction here. I cannot envisage what 5 million square kilometres of urban space in our sense would look like. And I don't think it's going to look like that. But ordinary human behaviour requires, privacy when you sit on the toilet, for example. It's got to be built space of some sort. I don't understand. I really don't know what the answer is. It's a very interesting problem.
I am really curious as to how you view what I would describe as system constraints on the very dense cities that you're describing. Some of the work I've done with megacities tends to look at a lot of natural barriers for them really evolving and thriving. And they break down frequently in our models because of lack of water and disease. And the more you put populations together, disease becomes so rampant. And unless we really crack, through technology, the disease issue, I think there are a lot of natural barriers that will prevent those megacities from becoming at least as dense as you describe. But I'm curious as to your perception of the natural barriers that at least so far a number of us are investigating.
There are two answers to your question. One is that in the main, I think, in terms of our aptitudes, we're broadly doing the right thing. If we have an uncontrollable population growth, we've just got to spread people out. We've got to put them on the other side of parks, the other side of rivers.
Well, infrastructure.
That's right.
We just don't have.
We need critically to do that. Now, the worry, and this is the thing that worries me whenever I look at Shanghai, is the bulk of Shanghai you can see has been built in what, 25 to 30 years? Well, down the line is a deterioration of infrastructure problem on a gigantic scale. The problem that's tied up, for instance, with disease is what happens when your dispersive infrastructure starts breaking down. And when you have to replace sewers, as they've had to in London. Once that infrastructure, once that material starts to crack, it then becomes part of the problem. And down the line, that is one of the things I think we really need to worry about, because we're not investing in the stockpile that we will need to deal with that problem. We're not investing in that at all. So I concur with your concern. I think the irony is that if you look at going to low density, we're probably doing the sensible thing at the moment, is if you keep people reasonably far away from each other and in relatively small clusters, and you give them separate services, that's probably a reasonable way to run their lives. But there's a point where that's going to run out. The other answer to your question is, if you had looked at pre-industrial cities, say, in 2000 BC, everywhere in the world you would have found settlements that were maybe between 5 and 20 square kilometers in extent. The Great Babylon, for instance, is 11 to 12 square kilometers in extent. By the time you get to 700 AD, Chang'an in China is 90 to 100 square K in extent. It's the greatest walled city of the pre-industrial world. It has 1 million people in it. And you would never have imagined, I think, from half a millennium earlier, that you could ever make something like Chang'an. The interesting thing about Chang'an is that Chang'an was relentlessly controlled. It was curfewed every night. Everybody was shut in their houses. The military patrolled the streets. But that's a model that broke down. The Chinese city that we know is the child of the following dynasty, the Song dynasty, where they had to work out how to have people live in cities without that regulatory control. So you could worry somewhat about our future is that the first model for getting to 10,000 square K is rigid control. But it won't last. It won't last. We we are tremendous subversives. We as a population are really good at breaking open structures of this sort just because we want to go out to dinner. That's how the Chinese city came into being. We want to go out to dinner, and we don't want the army stopping us. Yes, that's right. So those are the things that would concern me, is that it's perfectly possible to go that way with control. But the pattern we're on at the moment, the low-density pattern, is probably the most sensible solution to the problem at the moment. And I'd like to talk to you further about this. Thank you.
Why ochre? How could that spawn a revolution? What is there about ochre?
The thing you can do once you've got colour coding, and almost certainly ochre means you've got white and black as well, is you can mark yourself up as a particular kind of person who can be seen from a distance. So, for example, in traditional Aboriginal societies, you have what are called avoidance rules. Well, if you don't have to know the avoidance rules and know the person by face, you only have to see that they've got a white band on their forehead and you have to keep away from them. You've got a signalling system built into the behaviour of the community. If you can colour code the entrances to huts, so they're women only, for example. If it's red, it's women only. All you have introduced by ochre is a signalling system that can be used for a myriad of purposes. We don't know what purpose it's used for. And there are all sorts of elaborate arguments that it's to do with ritual and meaning and blood and reproduction and so on. I doubt that these hominid populations have got that kind of stuff in their head. But that you can use colour as a method of coding people so that you can see them at a distance and decide what to do in relation to them is pretty formidable.
And there was nothing before that?
Doesn't appear to be. The other interesting one, and the one that becomes very intriguing, is what does fire do? We've tended to think of fire as something that you have for practical reasons of cooking. But one of the critical things you see with fire in all human societies is it provides centrality. You can aggregate around it. So it may have had as powerful a persistence role from its centrality effect as it would have had from its value in cooking food. So you have to think, and stone tools are another phenomenon. The thing with stone tools is you can see them on the ground 20,000 years later. They tell you somebody was here. If you walk into an area and there's stone tools on the ground and you know they're not yours, you know something really important, which is maybe nick off, maybe don't stay here because you're in somebody else's space. So all these material things serve as signalling mechanisms. The problem for our thinking is that this is at such a rudimentary level that it's hard for us to envisage seriously that this is what we would call communication and signalling. It is so rudimentary, just extraordinary.
I keep having the feeling I missed something. What is your assumption about agriculture and ability to feed these populations?
Agriculture is plainly the economic driver that allowed sedentary communities to continue to expand. The key difference between the model I'm arguing and the conventional model is that the conventional model assumes that agriculture and the means to manage sedentary communities occurred concurrently. I'm not arguing that at all. All I'm saying is that those communities which had the means to be sedentary and did not use a substantial agricultural system would not have persisted. They simply could not have expanded. The dynamite, in terms of the behaviour of human beings, is that if you become sedentary, if you can behaviourally become sedentary, the key thing that happens is that the body fat ratio of the females rises. And when the body fat ratio of the females rises, the reproduction rate rises. So you can be a bunch of miserable sedentists who are quite ill, but you're producing babies at an astonishing speed. So the mobile groups further down the valley are doomed. All you will do is reproduce horribly and unhappily, and you will clean the happy hunter-gatherers down the valley out of the valley. That's the crucial thing. If you have an economic system in the form of agriculture that will keep on feeding you and your babies. If you don't, you're gone. So the interesting implication is the archaeological record should contain groups that sort of became sedentary but didn't do it. What we see in the archaeological record really overtly is the ones who became sedentary and had the economic agricultural engine to do it. That's the difference in the model I'm arguing. The economy, the economic requirement only specifies the outcome, which is bigger and bigger settlements with more and more people in them. It isn't the determinant of the growth starting in the first place. The Industrial Revolution, as I mentioned, has skewed our view of this process because the two happened simultaneously. We had the economic transformation and all the operational behavioural changes concurrently. That's the real difference.
We have been talking about population density. It seems to me that we are using the unit of humans and also human-to-human interactions. What if we miss out in future co-inhabitants that are non-humans, and that will kind of contribute to the population density? And is that one of the prerequisites, which is actually merging this entity that is capable of communicating and interacting with humans? I mean, what's your thoughts on that?
Well, there are two things. One of my worries would be that we, in my view, already know one of the prerequisites. We've got it. Most of you are carrying it in your pocket. That's a primitive ancestor of what will ultimately be needed. But one of the things that's going to do is to drive up interaction and engagement. At the moment, my guess is what it's going to do is increasingly disperse people, because you will less and less have to be engaged with them. But down the line, that technology is going to be used, as it already is to some degree, for massive engagement, massive aggregation, because you can organize aggregation with that machine. So my worry would be that we're moving into a situation where settlements could start moving up that density grade on the basis of only having some of the prerequisites and not having all of them. And that's really worrying, because what you have to bear in mind is that with the preceding transition, the Industrial Revolution, that occurred in 1820, 1830, but cities had reached 100 square kilometres 1,000 years earlier. We, in places like Chang'an, rode up to that 100 square limit and walked straight into it. Smack. Stop dead. And the city collapses. That's our most likely future. Riding up, hitting that limit, and collapsing. That's what would worry me. The question is, how fast would the next transition occur? Now, I think there was an earlier piece of your question which I missed. Well, the thing I think that worries me in terms of a long-term view of technology is that what I would guess with this very primitive computing technology we've now got is that we're moving towards a world in which you brush computing into your hair, you wear it in your clothes, you eat it in your Wheatie Flakes in the morning. It's everywhere. It's a completely pervasive phenomenon. You don't even notice it. Everything just gets done. You're tracked. All those kinds of processes go on. I can't see that having any specific implication for the degree to which people would pack together, but it has enormous implications for the way human social communication operates. I think smartphones are cute. You know, they're a little piece of tokenic technology. Fun, superficial fluff. But what they're leading to is not superficial fluff. It's really deadly serious. And we don't have a conception. Some of the people who work in digital technologies may have some notion of what they think is going to happen. But we're just happy with our smartphones, really.
Thank you very much. I'm just wondering how the demographic transition figures in this model. Because if indeed, you know, the world is heading towards zero population growth, might that actually really reduce the likelihood of these vast megalopolises appearing?
Well, it could stop the development of a 10,000 square K plus. The reason being that in terms of regular economics as they function now, my guess would be that a city of 100 million people has to be embedded in 1 billion people, just for services and function in various ways. So long as we've got these populations of 1 billion people on the planet, that it's possible to have such a concentration in a 10,000 square K city. The big worry is that if you get a transition of this sort, the economic driver that you will need to carry the population will make our concepts of population growth look funny. If you think of the way population on the planet grew at the Industrial Revolution, if you have another 10,000 square K transition driven by a set of working prerequisites and a new economy, the number of people on this planet in a very short order is going to be just staggering. And I'm not sure that that's a place we want to go. The other critical thing, and this is what we've learned from the archaeological record, is the early agrarian transition, the early urban transition we know very well from the Industrial Revolution. The critical thing that happens is the population goes up and it gets very unhealthy. It's not a good time. There are more and more people, but ill health is a very marked characteristic of those periods. So thinking about what such a transition would be like is not actually a very rosy picture at all. So if our efforts to bring population down and to reverse it can actually operate, we might actually prevent that occurring. That's the one thing that might stop it. The question is, do you want to stop it? If you want to make loads of money, don't stop it. If you want to make huge amounts of money as an entrepreneur, you need that 10,000 square K transition. You really do.
I'm wondering about the role of sort of political structures and ways of distributing power in these transitions. Because even at the very end there, you were saying about an entrepreneur wanting to make money, but it seems like you could make a case that that way of distributing power in terms of capitalism was really bound up with the last transition, right? And the next transition might be something else.
Sure.
But really, I'm wondering where sort of those kinds of power ideologies, where the arrangements come in, if they're kind of one of the prerequisites for a transition, or if they're, it seems like you could argue that they're what pull together the prerequisites, or you might argue that it's a kind of epiphenomenon, that it comes after the transition, you have some new form of power. So I'm really wondering how you see power structures fitting into the transitions.
The key is that I wouldn't view them as an epiphenomenon, but the critical part of my theoretical work as an archaeologist is to decouple the material from the social. The convention in archaeology is that the material is a reflection of the social. And I'm arguing that that's not the case. So you can, for instance, have gigantic material trends, as for instance the current drop to global low-density urbanism. But the Japanese do it one way, the Americans do it another, the Europeans do it another. There is no correlation between the specifics of their social way of doing it and the materiality of the phenomenon. The interesting question is that on that model, some ways of doing that socially will work better than others. That would be my guesstimate. So what becomes interesting for archaeologists in the model I'm arguing is that it frees up the debate about the nature of political and social systems in the past. It says that the formation of early urbanism is not the function of one determinate specific form of social organization. It could be done in all sorts of different ways in different societies. So that becomes a really interesting question. The big debate is whether what we've confused is the equifinal product, that there's only one way of really making it work. What we think of as the state, central power, bureaucracy, so on. That may be the way that you'll make such a thing work. That doesn't mean that that's the system that started it going. So that opens up a whole stream of debate in archaeology about the nature of the archaeological record. And it says that the operation that you can see in the archaeological record is a material operation, and there is a material explanation for what is going on. It doesn't mean the social isn't there. It means that you're free to analyze that as a phenomenon in its own right. So the interesting issue in the future is there could be any number of different ways of managing the next transition. Some of them will fail horribly. Some will work well. But that's the real world. The material does not determine what the social does. It simply doesn't. Social is much more freewheeling than that.
Thank you very much. Could I go with you to the future, a few steps then, and talk about settlements? My name is Jan Stamen from the Netherlands. That's what I had to say, yes. Designers are developing cities now which are enclosed, say a kind of ecological unit built in the air, closed, with nature encapsulated, full of digital, completely digitalized, but nature in it whatsoever it's in. Cities of 300,000 people and cities of 1 million. These are the concepts that I saw. Okay. Suppose something like that is going to happen. A total different concept of settlement. A completely technocratic concept of settlement and a completely technocratic concept of nature, connected to each other, and they call it a complete ecological system. Could you reflect on that? What does that mean for archaeology? That something like that can happen and, well, changes everything, I would almost say. Could you say what that means for settlement and so on? Well, speculate on that.
There are two answers. For any size range from 1 million people now up to managing 100 million, this would seem to be the beginning kind of model that you might use. After all, you're not going to leave scruffy pieces of nature hanging around if you can completely industrialize them into a landscape and make it all completely managed. Whether you are entirely confident that humans can manage that in the long term is an interesting question. I don't know what these plans envisage. It would seem highly likely to me that that's one path people will go on. Another one might be that you would shift to a quite different model and you would leave clear tracts of open nature and you would pack humans in some other way. or you stack them up. There have been models of high altitude buildings. That will be another path to go on. I'm not sure I or many other people would want to. But it would seem to me that what you're going to see over the next 40 to 50 years is dozens of extremely innovative ways of trying to do this. Because the problem down the line is that you can be very fancy and very imaginative and very clever about organizing 1 million people, say, in the Netherlands. But you have a highly organized infrastructure, you have people paying their taxes. It's a massively expensive exercise. That's not going to be exported to the burgeoning cities of Africa. That may work in some areas in Europe. So there are going to be plural models. One of the interesting things to do, obviously, would be to go and look at what the Japanese are trying to do. Somebody was telling me the other day that on the outskirts of Japanese cities, you don't get the pattern in European cities of big open pieces of land with big houses on them. You get more small houses. Now, I don't know whether is that the case, son? That's a very interesting thing to look at, because that seems to me to infringe just about every European concept of real estate that you could possibly get into. But plainly, this is something that there is a mechanism to use. So one of the things we would need to start doing, and it would relate to the whole business of how places work, is start looking at what everybody's doing. Start seeing what the variety of models are, because the only thing that's going to keep us going is jumping, keeping variety. One model isn't going to work. It's going to have to be variety. That's the critical thing we've got to do.
I think we are there. May I allow myself to have a last question? Yes, yes. I allow just a last question, very, very
Sure.
brief.
I've run out of water.
Yes, we have more water.
That's okay. Don't worry.
Just a question that I'm dreaming that McLuhan might have asked you. So in your timeline of transitions,
Yeah.
do you think that the main transition point have to do with the rise and fall of big empires? And if yes, do the big empires come before, during the transition, or after?
After, well after. You have to organize yourself on a relatively local scale first. The thing you have to bear in mind when you're looking at the Industrial Revolution is that the Industrial Revolution changes are going 1,000 times faster than the previous ones. So what you see is an incredibly compressed cultural process in what we see in the Industrial Revolution. When you look at the early urban growth, Uruk gets up to 5 square K and controls a chunk of the middle Mesopotamian plain. It takes at least 1,000 years for the Mesopotamian cities to get to taking over seriously the surrounding land. So the model generally is that you get your empires later.
Thank you.
Pleasure. Oh, I've got to hold it.
Yes, come close, come close.
Thank you. Thank you very much. Thank you, John.
Okay, thank you. Before everybody goes, I have one announcement to make. That is, all those of you that have registered for the banquet tonight, unless